Assalamu alaikum. Welcome to lecture number 44 of the course on statistics and probability. Students, you will recall that in the last lecture I discussed with you analysis of variance and experimental design. Towards the end of the last lecture, we began the discussion of the randomized complete block design, another very important design, and you will recall that I presented to you an example, the detailed discussion of which we will be doing in today's lecture. As you now see on the slide, in a feeding experiment of some animals, 4 types of rations were given to the animals that were in 5 groups of 4 each. The following results were obtained. Students, you can see a bivariate table. The top row represents the 4 types of rations, and the first column gives you the 5 groups into which the animals had been divided. So, if we study the first column, the values 32.3, 34.0, 34.3 and so on represent the gains in weights due to ration A, and the first value pertains to the animal who is in group 1, the second one for the animal who is in group 2, and so on. Now, we are required to perform an analysis of variance and to state our conclusions. Students, आपने देखा कि इस problem में weight gain due to the rations, that is the variable of interest. और हम ये assume कर रहे हैं कि इस experiment का purpose ये है कि हमें पता चले कि वो जो 4 राशन हैं उनमें से कौन सा है कि जिसकी वजह से we get the maximum weight gain. The purpose is to increase the weights of those animals, and we are trying to compare the different rations in this regard. Now, what is the hypothesis testing procedure? Very similar to what we did last time, but students, the essential difference is that last time we were talking about the completely randomized design, and analysis of variance in that situation is called one-way analysis of variance. आज इस वक्त हमारे पास सिर्फ ट्रीटमेंट्स ही नहीं यानी राशंस ही नहीं है 4 किस्म के, बल्कि we have also categorized those animals into 5 groups, and technically each group is called a block. We are now talking about the randomized complete block design. और जैसा कि मैंने लास्ट टाइम भी एक्सप्लेन किया था, जब हमें ये महसूस हो कि हमारा एक्सपेरिमेंटल मटेरियल होमोजीनियस यानी सिमिलर नहीं है and there are some dissimilarities, then we do the blocking. यानी जो relatively homogeneous material है उसको एक ब्लॉक में डाल दें, दूसरी किस्म का जो है उसको दूसरे ब्लॉक में डाल दें, and so on. So, let us now do the hypothesis testing procedure step by step. As you now see on the slide, step 1 is the formulation of the null and the alternative hypotheses, and you will be interested to note, students, that in this particular situation we are in a position to form H0 and HA not only for the treatments but also for the blocks. Our primary interest, of course, is in the treatments. H0 says mu A is equal to mu B is equal to mu C is equal to mu D, but H alternative is that not all the treatment means are equal. Similarly, we have the null hypothesis H0 dash saying mu 1 is equal to mu 2 is equal to mu 3 is equal to mu 4 is equal to mu 5, and H dash alternative says not all the block means are equal. आइए इन दोनों सेट्स ऑफ hypotheses को बारी बारी कंसिडर करते हैं. जैसा कि मैंने कहा, हमारा प्राइमरी इंटरेस्ट तो ट्रीटमेंट्स में है. वो 4 राशन जो हैं, which one of them is able to produce the maximum weight gain? That is what we want to know. The null hypothesis says that on the average, the weight gain is the same for A, B, C and D, and the alternative says that at least one of them is different from the others. Now, what about the other set of hypotheses, H naught dash and H A dash? जिस तरह मैंने लास्ट टाइम एक्सप्लेन किया था स्टूडेंट्स, अगर हम फर्टिलाइजर्स को कंपेयर करना चाह रहे हैं और हम उन्हें खेत में मुख्तलिफ खेतों में बोएंगे, तो मुमकिन है कि जो खेत नहर के नज़दीक हों उनकी फर्टिलिटी डिफरेंट हो फ्रॉम द सॉइल विच इज़ फर्दर अवे फ्रॉम द कैनाल. ये बात आपको याद होगी. इसी तरह ऑब्वियसली जानवरों की जो ग्रुपिंग की गई, कोई ना कोई क्राइटेरियन था जिसके तहत किया गया. बट स्टूडेंट्स, this analysis of variance that we are going to do in this example, the two-way ANOVA, it enables us to test this hypothesis, as you saw on the screen, that the null says that mu1 is equal to mu2, equal to mu3, equal to mu4 and equal to mu5. यानी वो जो weight gain है ना, that is the same for all the groups. और alternative ये है that at least one of the groups is different from the others. तो इस बात का मतलब क्या है? इसका मतलब ये है कि अगर हम बाद में after we perform the analysis, if we accept the null hypothesis कि जी वो पांचों ग्रुप्स के लिए weight gain बराबर है, तो इसका मतलब तो ये हुआ ना कि that grouping was actually not required. क्योंकि अगर वो पांचों के लिए एक ही जैसा weight gain आना है, तो फिर उस हवाले से those animals are homogeneous and we did not need to group them into various groups. लेकिन अगर हम null को reject करेंगे और alternative को accept करेंगे, which says that at least one of them is different from the others, then we can say that this kind of grouping or blocking was justified. The second step of the hypothesis testing procedure is the level of significance, and as you now see on the screen, we may take alpha as 5% as we usually do. The third step is the test statistic. Now, in order to test H naught versus H A, the test statistic is F is equal to mean square treatment over mean square error, and in order to test H naught dash versus H A dash, the test statistic is F is equal to mean square block over mean square error. The fourth step is the computation of the test statistics, and for this purpose we have to carry out quite a lengthy computation. The numbers that are in the brackets inside the body of the table, they represent the squares of the various values that we have in our data set. The row under the data values and their squares is T dot j, the sums of the various columns T dot 1, T dot 2 and generally T dot j. Similarly, the column to the right of the data values is denoted by bi dot, and these are the sums of the various rows b1 dot, b2 dot and generally speaking bi dot. Students, यहाँ पे एक बात नोट करें, ये जो T और B है ना, actually T stands for treatment and B stands for block. चूँकि columns जो हैं वो treatments को represent कर रहे हैं, इसलिए उनके जो totals हैं उन्हें हम T.1 और T.2 वगैरह कह रहे हैं, और जो rows हैं they are representing the blocks or the groups into which the animals have been divided. इसलिए उनके जो sums हैं उन्हें हम B1 dot वगैरह कह रहे हैं, यानी B for block. All right, going back to the slide once again. The row under T dot j is T dot j square, and similarly on the right side on the top, the column to the right of bi dot is bi dot square. इसके बाद अगर आप सबसे नीचे वाली रो को देखें और सबसे आखिरी कॉलम को देखें तो स्टूडेंट्स आपको सिग्मा आई एक्स आई जे स्क्वायर नीचे और सिग्मा जे एक्स आई जे स्क्वायर राइट पे नज़र आ रहे हैं. इसकी वजह यही है कि वो जो स्क्वायर्स उस टेबल के बॉडी के अंदर हैं, अगर आप उनको डाउनवर्ड ऐड करेंगे then of course you are summing over I, लेकिन अगर आप उन्हें row wise ऐड करेंगे then obviously you are summing over J. Now when you will add the sums that you have already obtained, may you do it using the bottom row, may you do it using the last column, the grand total of the squares of the data values comes out to be 21725.22. Similarly, the sum of all the data values comes out to be 656.4 as you can see on the slide, and sigma bi dot square is equal to 86258.04, whereas sigma t dot j square comes out to be 108387.48. Students, बस यही एक थोड़ी सी लंबी कैलकुलेशन है. Once you have obtained all these sums, after that it is fairly simple. जो फॉर्मूले हमने लास्ट टाइम डिस्कस किए थे with reference to the completely randomized design, वही फॉर्मूले तकरीबन यहाँ पे इस्तेमाल होंगे. The difference being that not only are we going to be able to compute the treatment sum of squares in this problem, but also we will be computing the block sum of squares. As you now see on the slide, the total sum of squares is equal to double summation xij square minus t dot dot square over n, and this comes out to be 182.17. The treatment sum of squares is given by sigma j t dot j square over r minus t dot dot square over n, and the answer is 134.45. Students, इस मरहले पर आपको मैं याद दिलाना चाहती हूँ कि t डबल डॉट स्क्वायर ओवर n, इसको हम कहते हैं correction factor, and this of course is involved in the formulae when we are trying to apply the shortcut formula. अब जिस तरह से अभी अभी हमने treatment sum of squares compute किया, बिल्कुल इसी तरह से we are also going to be able to compute the block sum of squares, and as you now see on the screen, the block sum of squares is equal to sigma I bi dot square over c minus t dot dot square over n, and the answer is 21.46. It should be noted that c represents the number of observations per block, in other words the number of columns. Having computed the total SS, the treatment SS and the block SS, students, the error sum of squares is given by the total sum of squares minus the sum of the treatment sum of squares and the block sum of squares, and substituting the various values that we just obtained, the error sum of squares comes out to be 26.26. Students, आपको याद होगा कि लास्ट लेक्चर में भी जब हमने completely randomized design वाला एग्जाम्पल किया, we carried out elaborate calculations like we just saw for this example. But what was the purpose of these calculations? The ANOVA table. अब इस एग्जाम्पल में जो ANOVA table हम construct करेंगे, that is a kind of an extension of the one that we had last time. And as you now see on the slide, the columns of the ANOVA table are just as we had last time: source of variation, degrees of freedom, sum of squares, mean square and f. लेकिन अगर आप उसकी जो रोज हैं उनको देखें तो आप देखेंगे कि एक रो का इजाफा हो गया है. The first source of variation is between treatments, that is between the rations. The second is the variation between blocks, that is the variation between the various groups into which those animals have been divided. The overall variation is represented by the term total, and error variation represents the variability that exists within each treatment block combination that we have. Students, ये जो last source of variation मैंने बयान की, मैंने कहा कि this is the error variation is representing the variation that is within each treatment block combination that we have. जैसे मैंने कहा 4 treatments हैं यानी 4 राशन हैं, 5 blocks हैं, 5 different groups. तो students, इन 2 बातों की वजह से overall we have 20 different situations, 20 different treatment block combinations. Yani treatment A with group 1, treatment A with group 2 and so on. और इसी तरह जो 20वीं treatment block combination है वो क्या है? Treatment D with group 5. कह ये रहे हैं कि इनमें से किसी एक combination पर अगर आप ये experiment बार बार करें यानी replication करें तो हर मर्तबा आपका रिजल्ट एक नहीं आएगा. You will get different results in spite of the fact that the experimental condition is the same. कि वही ट्रीटमेंट वही ब्लॉक लेकिन एक जानवर के लिए वेट गेन कुछ और आएगी और दूसरे जानवर के लिए कुछ और उसी ट्रीटमेंट ब्लॉक कॉम्बिनेशन के अंदर. सो दिस इज कॉल्ड द विद इन वेरिएशन. और ये जो सारी कॉम्बिनेशनों के लिए इस तरह की वेरिएशन है उनका जो कंबाइंड इफेक्ट है दैट इज व्हाट यू हैव इन दिस कॉलम in our ANOVA table. Going back to the slide, students, we note that the degrees of freedom corresponding to the overall variation is 20 minus 1, that is 19. In other words, the total number of treatment block combinations that we have, in other words, R into C minus 1, where R represents the number of rows and C represents the number of columns. After all, students, do we not have 5 rows and 4 columns, 5 blocks and 4 treatments? तो जैसा मैंने कहा, the degrees of freedom for the total is given by R into C minus 1, that is 5 into 4 minus 1, that is 20 minus 1, that is 19. The degrees of freedom for treatments is 4 minus 1, that is 3. Why? Because we have 4 treatments, 4 columns. So, C minus 1, in other words, is the degrees of freedom for treatments. The degrees of freedom for blocks is 5 minus 1, that is R minus 1, and that is equal to 4. And last but not the least, the error degrees of freedom are obtained by subtracting the sum of 4 and 3 from 19. In other words, 19 minus 3 minus 4 gives us 12 as the error degrees of freedom. Students, ये जो formulae हैं degrees of freedom के, as you can see, they are extremely simple. The only thing that you have to keep in mind is कि अगर आपने treatments को column wise लिया है तो जाहिर है कि degrees of freedom for treatments will be C minus 1. लेकिन अगर आप इसके उलट कर लें, if you take treatments along the rows, then the degrees of freedom for the treatments will become R minus 1. And since the blocks will be along the columns in this case, therefore, the degrees of freedom for the blocks will become C minus 1. So, it is fairly simple. All right. Let us go back to the slide and concentrate on the third column, that of the sum of squares. As we computed a short while ago, the total sum of squares is 182.17. The sum of squares for treatments is 134.45, that for blocks is 21.46, and the one for error, by subtracting 134.45 plus 21.46 from 182.17, the error sum of squares is 26.26. The column of mean square is very easily obtained by dividing the values in the sum of squares column by the corresponding degrees of freedom. Therefore, 134.45 divided by 3 gives us 44.82 as the treatment mean square. 21.46 divided by 4 gives us 5.36 as the block mean square, and 26.26 divided by 12 gives us 2.19 as the error mean square. Students, ये सारी कैलकुलेशनें हम किस मकसद के लिए कर रहे थे? Of course, in order to obtain our test statistic. जैसा कि मैंने पहले कहा, इस केस में we are able to test two sets of hypotheses, and correspondingly we have two F values. Coming back to the slide, F1, which is the ratio of the treatment mean square to the error mean square, that is 44.82 divided by 2.19 comes out to be 20.47, and F2, which is the ratio of the block mean square to the error mean square, comes out to be 5.36 over 2.19 equal to 2.45. Students, of course, you remember that the next step is the critical region, और इस मर्तबा interestingly we have two different critical regions. वजह क्या है कि पहला जो F निकाला है, F1, that follows the F distribution having 3,12 degrees of freedom, but the other one, F2, that follows the F distribution having 4,12 degrees of freedom. ये मैंने क्यों कहा students? Do you not remember, according to what we did last time, कि वो जो F हम निकालते हैं उसकी जो degrees of freedom होती हैं, they are the ones corresponding to what we have in the numerator of our F, that is our first degree of freedom, and the one corresponding to what we have in our denominator, that is the error mean square. उसकी जो degrees of freedom हैं, that is our second degree of freedom. So, as you now see on the slide, since the level of significance in each case is 5%, therefore, the critical region for testing H naught against H A is given by F greater than or equal to F 0.05, 3, 12, and consulting the F table, this value is equal to 3.49. Similarly, the critical region for testing H naught dash against H A dash is given by F greater than or equal to F 0.05, 4, 12, and this is equal to 3.26. The sixth and last step is the conclusion. Since our computed value of F1, that is 20.47, exceeds the critical value 3.49. Therefore, we reject the null hypothesis regarding the treatment means and conclude that there is a difference among the means of at least two of the treatments. That is, the mean weight gains corresponding to at least two of the rations are different. On the other hand, since our computed value of F2, that is 2.45, does not exceed the critical value 3.26, therefore, we accept the null hypothesis regarding the equality of the block means, and thus we can conclude that the blocking, that is the grouping of the animals as it was done in this experiment, was actually not required. Students, आपने नोट किया कि ब्लॉक्स वाला जो हमारा hypothesis था, the null hypothesis has been accepted. That is, mu1 is equal to mu2 is equal to mu3 and so on up to 5. तो इसका मतलब यही हुआ ना कि वो जो ब्लॉकिंग हमने की थी, वो ग्रुप्स जो हमने बनाए थे, that was actually not required. लेकिन अब तो जाहिर है कि एक्सपेरिमेंट परफॉर्म हो चुका है, डेटा हासिल हो चुका है. अब इस इंफॉर्मेशन को हम आइंदा इस्तेमाल कर सकते हैं. अगर हमने फ्यूचर में इस तरह का एक्सपेरिमेंट दोबारा करना हो, तो हम इस रिज़ल्ट को सामने रखते हुए अगली मर्तबा इस तरीके से ग्रुपिंग नहीं करेंगे, करने की ज़रूरत नहीं है. But what about the hypothesis that our primary interest lies in? You remember, we are basically interested in comparing the 4 rations, and we want to know which one of them gives the highest weight gain. Students, जैसे कि आपने नोट किया, हमारी जो computed value आई थी, that was much larger than the critical value. Therefore, we have rejected the null hypothesis, और हमने ये conclude किया है कि वो चारों जो rations हैं, they are not all similar with regard to weight gain. तो फिर naturally ये सवाल पैदा होता है कि कौन सा वाला है which is the best? The answer to this question, students, can be obtained by applying what is called the least significant difference test, or the LSD test. And as you now see on the screen, according to this procedure, we compute the smallest difference that would be judged significant and compare the absolute values of all the differences of means with this smallest difference. This smallest difference is called the least significant difference, or the LSD, and is given by LSD is equal to T alpha by 2 new degrees of freedom multiplied by the square root of twice the mean square error divided by R, the number of observations per treatment. And it should be noted that nu stands for the error degrees of freedom. Students, जैसा कि हमने और बहुत सारे जो procedures डिस्कस किए, उनकी डिटेल्ड मैथमेटिकल डेरिवेशंस हम इस कोर्स में नहीं कर रहे. इसी तरह इसकी डिटेल्स में हम ज़्यादा मैथमेटिकल डिटेल्स में तो नहीं जाएंगे, लेकिन the point that I want to convey to you is that this is basically the Ttest, or let me say something that we have derived from the Ttest that I have already discussed with you when we were wanting to compare two population means. यानी situation ये है students कि 4 rations हैं और वो 4 means हम compare करना चाहते हैं. हमने decide कर लिया according to the analysis of variance that we conducted that not all 4 of them are equal. तो फिर अगली बात यही बनती है ना कि हम उनको pair wise compare करें, A with B, A with C, A with D, and so on. सो अगर हम उस तरह करने लगे तो बहुत बार बार हमें टी टेस्ट करना पड़ेगा. टेस्टिंग म्यू ए इक्वल टू म्यू बी वर्सेज म्यू ए नॉट इक्वल टू म्यू बी, उसके बाद टेस्टिंग म्यू ए इक्वल टू म्यू सी एंड सो ऑन एंड सो फोर्थ. तो ये जो LSD प्रोसीजर है, दिस इज अ प्रोसीजर by which all this lengthy work is summarized और हम एक ही मर्तबा में ये डिसाइड कर लेंगे कि which two or three are different and which are not. So let us apply it to this example. As you now see on the screen, the least significant difference is equal to T alpha by 2 nu square root of twice the MSE over R, and in this problem MSE is equal to 2.19, R is equal to 5, and nu, the error degrees of freedom, equals 12. Since our level of significance is 5%, therefore T alpha by 2 nu is equivalent to T 0.025 12 degrees of freedom, and students looking up the T table and then performing all the calculations, the LSD comes out to be 2.04. Students, ये जो result है ना, इसको understand कीजिए. This is the least difference between any two treatment means that would be judged significant. हमने आफ्टर ऑल इसका नाम क्या रखा हुआ है? लीस्ट सिग्निफिकेंट डिफरेंस. तो इसका मतलब ये हुआ कि हमारी जो 4 ट्रीटमेंट्स हैं, हम अपनी जो डेटा वैल्यूज़ हैं उनकी मदद से इन सब की मीन्स निकालेंगे, एंड ऑफ कोर्स व्हाट वी विल बी गेटिंग आर नॉट म्यू ए, म्यू बी, म्यू सी और म्यू डी. वो तो अननोन पैरामीटर्स हैं जिनके बारे में हम ये सारा इन्फ्रेंस करना चाहते हैं. But of course, we will obtain x bar A, x bar B, x bar C and x bar D. और उसके बाद we have to compare the differences between these respective x bars with the least significant difference that we have just computed. As you now see on the slide, the totals of the first, second, third and fourth columns are 172.1, 173.9, 168.5 and 141.9, and of course these are exactly the same quantities that we have already computed: T dot 1, T dot 2, T dot 3 and T dot 4. लेकिन इस वक्त हमारी इंटरेस्ट टोटल्स में नहीं बल्कि मीन वैल्यूज़ में है, एंड हेंस डिवाइडिंग 172.1 by 5 we obtain x bar A equal to 34.42. Similarly, dividing 173.9 by 5, x bar B is 34.78 and so on. In order to apply the LST test, students, we should arrange these sample means that we have just obtained in ascending order of magnitude. Doing that, x bar D comes first because it is the smallest value, 28.38. It is followed by x bar C, which is 33.70. This is followed by x bar A, 34.42, and last but not the least, we have x bar B equal to 34.78. Students, ये जो हमने ascending order में arrange कर दिया, this is for convenience. अभी थोड़ी देर के बाद आप देखेंगे कि because of this, we are very easily able to explain which means are not significantly different from each other and which are. So, as you now see on the slide, we will be drawing lines under pairs of adjacent means or sets of means that are not significantly different. And in this example, you can see that the line starts under x bar c and it goes up to x bar b. Students, इसका क्या मतलब है? इसका मतलब ये है कि जो डिफरेंस है 33.70 और 34.42 के दरमियान, the absolute difference between these two numbers is less than 2.04, the least significant difference that we computed a short while ago. Not only this, but also the difference between 34.78 x bar b and 33.70 x bar c. This difference is also less than 2.04, the LSD. चूँकि x बार a, x बार c और x बार b के दरमियान फॉल कर रहा है, तो जाहिर ही है कि x बार a और x बार b के दरमियान जो एब्सोल्यूट डिफरेंस है, that will also be less than the LSD. The only sample mean which is standing out as being significantly different from the rest is x bar d. आप देख रहे हैं ना कि वो जो लाइन हमने ड्रॉ की वो x bar d से स्टार्ट नहीं हुई. We started this procedure from x bar d, but we found that the difference between x bar d and x bar c, the absolute difference between these two, is greater than 2.04, and therefore we were not able to draw a line underneath these two so that we could have said that they are not significantly different. लेकिन उसके बाद x bar c, x bar a और x bar b जो हैं उनके दरमियान जो differences हैं, they are less than the LSD, and therefore we can say that these three are not significantly different. Students, ये इतना मुश्किल नहीं है जितना आप समझ रहे हैं. ये हम करते इस तरह से हैं कि हम स्टार्ट लेते हैं पहली अपनी जो पहली मीन होती है वहाँ से. We start trying to draw this line. अगर वो पहले में ही नहीं ड्रॉ की जा सकती because of that difference being larger than the LSD, then of course we just don't do that. But then we start from the second one. फिर हम second से शुरू हो जाएंगे जहाँ तक हम जा सकें, और उसके बाद हम third से भी start ले सकते हैं, and we can go up to wherever we can go. So I would like to encourage you to attempt quite a few questions on this particular topic, which you can find in your own textbook as well as in other books. But students, please keep one thing in mind. The LSD test, the occasion for applying this test, does not even arise if we accept the null hypothesis that we had in the analysis of variance. यानी अगर हमारा वो जो पहला hypothesis था ना, that mu a is equal to mu b is equal to mu c is equal to mu d, अगर वो accept हो जाता तो फिर तो सवाल ही पैदा नहीं होता ना कि आप ये LSD टेस्ट लगाएं. ये तो सिर्फ उस सूरत में लगेगा if you reject that null hypothesis and then you say to yourself कि जी ये तो फिर इसका मतलब है कि वो चारों राशन एक जैसे नहीं हैं, तो फिर naturally ये सवाल पैदा होता है कि which one is better or which one is worse and so on. Students, इस particular example में which ration is better, which is worse? Do you know? According to what we did just now, C, A and B are not significantly different. The only one which is significantly different from the rest is ration D. Lekin, haven't you noticed that it has occurred on the left end of the four when we arrange them in ascending order? इसका मतलब ये है that it is not the best one, rather it is the one which has the poorest performance with regard to weight gain. इसका मतलब ये हुआ कि अगर हम रिकमेंड करना चाहते हैं फार्मर्स को कि अगर आपने इन जानवरों का वेट बढ़ाना है तो आप फलां राशन इनको दें, तो हमारी रिकमेंडेशन क्या होनी चाहिए? स्टूडेंट्स, वी मे रिकमेंड C, A or B because our statistical analysis has shown that they are not significantly different with regard to weight gain. तो वो फिर उसके बाद ऐसे होगा कि depending on the availability or the price or other such criteria, they can decide whether they want to have C, A or B. But surely on the basis of the analysis that we just conducted, we will not recommend ration D. After all, that has stood out as being different significantly from the rest and not having the best but the poorest performance. Students, this brings us to the end of our discussion regarding analysis of variance and experimental design. The next concept that I am going to discuss with you is the chi-square test of goodness of fit. You might recall that in lecture number 28, when we were discussing probability distributions, we did an example in which we fitted the binomial distribution to real data. और आपको याद होगा कि हमने वो probabilities compute की जो binomial formula के तहत हमें मिलनी थी, and then we also found the expected frequencies. And after that, when we were trying to compare the observed frequencies with the expected ones, we said that there does not seem to be much discrepancy between the two, and it appears that our fit is a good fit. लेकिन आपको ये भी याद होगा कि मैंने उस वक्त आपसे कहा था कि there is a formal procedure by which we can judge whether or not our fit is good, and that is exactly what I am going to discuss with you right now. Before we go to the test, let us very quickly review the chi-square distribution on the basis of which we will be conducting this test. So, as you now see on the slide, the chi-square distribution is a continuous distribution ranging from 0 to infinity. The number of degrees of freedom determines the shape of the chi-square distribution. Generally speaking, the chi-square distribution is positively skewed, but the skewness decreases as nu increases, and we can say that the chi-square distribution tends to the normal distribution as the number of degrees of freedom tends to infinity. All right, having reviewed the basic properties of the chi-square distribution, students, let us proceed to the chi-square test of goodness of fit. And I would like to do this with the help of exactly the same example that we considered in lecture number 28. As you now see on the slide, the example read, the following data has been obtained by tossing a loaded die 5 times and noting the number of times that we obtained a 6. Fit a binomial distribution to this data. The data was x values 0, 1, 2, 3, 4, 5, where x of course represents the number of 6s in 5 tosses of the loaded die, and the column of frequencies read 12, 56, 74 and so on, so that the total was 200. In order to fit a binomial distribution, first of all we find the sample mean x bar, and for this purpose we find sigma f of x, which is 398, and dividing by sigma f, which is 200, our x bar comes out to be 1.99. Now, putting x bar equal to np and noting that n is equal to 5, we obtain p is equal to 0.398. Hence, the binomial formula is 5cx 0.398 raised to x into 0.602 raised to 5 minus x. Students, obviously, we will be substituting the values of x in this formula. X is equal to 0, 1, 2, and in this way we get all the probabilities, and after that we will be multiplying each of them by 200, the total number of times this experiment was repeated, and that will give us the expected frequencies. So, as you now see on the screen, the probabilities are 0.07907, 0.26136, and so on, and the expected frequencies come out to be 15.8, 52.5, 69.1, and so on. Now, our interest lies in determining whether the expected frequencies are quite close to the observed ones, or is there a considerable amount of discrepancy between the two. It appears that there is not a tremendous amount of difference between the observed frequencies OI and the expected frequencies which are denoted by EI. Students, अगर हम subjectively करें तो मुमकिन है कि हम गलती कर जाएं. So why not adopt the proper formal procedure? And the chi-square test of goodness of fit has exactly the same pattern, the 6 steps that we have in any hypothesis testing procedure. As you now see on the slide, the null hypothesis in this particular situation is that the fit is good, and the alternative is that the fit is not good. Students, आप सोच रहे होंगे कि ये तो कोई अजीबो-गरीब different किस्म के hypothesis बन गए. Actually, the underlying mathematics is such that this is the way we should formulate our null and alternative hypotheses in this particular situation. अब जाहिर है कि उस डिटेल में हम नहीं जाना चाहते, but this is the point that if we say that the fit is good, then we can proceed in the manner that we would like to proceed, and keeping in mind that we always begin by assuming that H naught is true. This is the assumption which will lead us to the steps that we have after this. The second step is the level of significance, and we can set it at 5%. The third step is the test statistic. And as you can see, the test statistic in this particular situation is given by the summation of the quantity OI minus EI whole square divided by EI, and it can be mathematically proved that if H naught is true, then this statistic follows the chi-square distribution having k minus 1 minus r degrees of freedom. Students, अब सवाल ये है कि k क्या चीज़ है, r क्या चीज़ है. k is the number of x values that we have. यानी शुरू इस बात से करते हैं, हमारे पास क्या वैल्यूज़ थी x की, 0, 1, 2, 3, 4, 5. तो उस हिसाब से k is equal to 6. थोड़ी देर के लिए इस बात को एक्सेप्ट कर लेते हैं. और r क्या है? The number of parameters that we estimate from the sample data. बायनॉमियल डिस्ट्रीब्यूशन के 2 पैरामीटर होते हैं, n and p, और आपको याद ही होगा और सारी डिस्कशन जो हमने की उससे भी वाज़े है that n is already known, इसलिए कि हमें मालूम था कि हमने वो जो लोडेड डाई है that is being tossed 5 times, so n is equal to 5. लेकिन आपको याद है ना कि अभी वो पूरा प्रोसीजर हमने किया जिसके तहत p was estimated from the sample data. क्यों? इसलिए कि हमारी इक्वेशन थी x बार इक्वल टू एन पी, हालांकि असल इक्वेशन होती है म्यू इक्वल टू एन पी. चूँकि म्यू अवेलेबल नहीं था, हमने उसको x बार से रिप्लेस किया और P उसके ज़रिए निकाला. So that is an estimated value of P, and so this is one parameter that we are estimating from the sample data. जैसे मैंने अभी कहा, R is the number of parameters that you estimate from the sample. तो इस क्वेश्चन में R is equal to 1. एक ही पैरामीटर हमने सैम्पल डेटा से एस्टिमेट किया है. स्टूडेंट्स, थोड़ी देर पहले मैंने कहा था दैट आवर स्टैटिस्टिक सिग्मा OI minus EI whole square over EI follows the chi-square distribution having k minus 1 minus r degrees of freedom. अगर k 6 हो और r 1 हो, then 6 minus 1 minus 1, that is 4 degrees of freedom. But having said all this, students, there is a very important point that I need to convey to you, और वो ये है कि अगर किसी भी x वैल्यू की expected frequency 5 से कम हो जाए, then we have to combine some of those x values so that our expected frequency becomes greater than or equal to 5. As you now see on the slide, in this example, the expected frequency against x equal to 5 is equal to 2.0, and this is less than 5, and hence we will combine the x value 4 with the x value 5, and thus adding the two expected frequencies pertaining to these two x values, our expected frequency of the combined category will come out to be 17.1. Also, the observed frequency of the combined category comes out to be 1 plus 18, that is 19, and thus the effective number of categories that we now have is no longer 6, but 5. As such, our statistic will follow the chi-square distribution having 5 minus 1 minus 1, that is 3 degrees of freedom. The fourth step is the computation of the test statistic, and for that purpose we construct the columns of OI minus EI and OI minus EI whole square divided by EI. Now, the sum of this last column is equal to our test statistic, and in this problem it is equal to 2.69. Students, as you know, the fifth step is the determination of the critical region, and I would like to point out that the underlying mathematics of this test is such that it should always be a right-tailed test. Therefore, looking at the chi-square table, under 0.05 against 3 degrees of freedom, we obtain, as you now see on the screen, the critical value 7.82. The last step is the conclusion, and students, since our value 2.69 is less than the critical value, therefore, we accept H naught and conclude that the fit is good. In today's lecture, we discussed the randomized complete block design and two-way analysis of variance. Then we went on to the LSD test, and last but not the least, we discussed the chi-square test of goodness of fit. Students, in the next lecture, I will be discussing with you the chi-square test of independence. Best of luck, and until next time, Allah Hafiz.